Okay, so this is a real layman's terms way of describing what's actually going on inside of the PLC as it's doing whatever it's programmed to do. Okay, so the components of the PLC, of course, are your CPU, the PLC itself. You've got some input cards, and then you've got some output cards. Okay, so if this is an expandable PLC, you could have a dozen of these and a dozen of these, or 100 of these, or the amount or the size of the amount of input cards and output cards is really quite astounding, depending on the size of your PLC itself. Okay, so on your input cards, both the input cards and output cards work on optio isolation. Okay, so what goes on is on your input cards, you can think of it as having a set of lights with a set of, let's say, photo eyes looking at each of those individual lights. Okay, they're all connected internally to the power supply. We have a common terminal on the input card, so this will be, if it's a 24 volt system, this is your positive 24 volts. You take that out and then you go to your field devices. From your field devices, you come back and you connect those onto the input terminals, so the screw terminals on the input cards, and they're going to be addressed just 0, 1, 2, on and on and on. Okay. If you've got a larger PLC, sometimes there'll be this will mean the first digit will be which card is it on, and then the next two are which address within the card. There's a variety of different addresses that get used, and it's PLC specific, but the generalization of it is you're going to have an input, and then you're going to have an address or a physical location, if you will, that the PLC is looking for. Okay, so what happens in here is when you see your common terminal ran out to these buttons, from the button back to the input terminal. When you push this button and you close this circuit, this lights up. When this light lights up, this eye sees that light and sends that information to the CPU, which is basically the brain. Okay, so there's no way that the current that's traveling through any of your field devices can get back to the CPU, because the CPU is just using this optio isolation. It's just looking for what the status is of these devices. Okay, and then once it sees this light up, it tells the eye tells the brain that input is now true, and the CPU does with it whatever the program tells it to do. Outputs work exactly the same way, but in reverse. So the CPU lights a set of lights. Each light is shining on a light-dependent resistor, so this resistor has a really high resistance when it's dark. As soon as light shines on it, the resistance on this goes down to nothing. So once this lights up, this resistance becomes 0, and current can travel from the output terminal, which is addressed the same way the inputs were. Start with an output and then which number it is. That'll send power out to whichever output is, or whichever device is connected to that output. Okay, so the way the simplest program we can make is we have one input controlling one output. Okay, so input number 000 is gonna, when it becomes true, it's gonna activate output 000. So the process is we push this button, this light lights up, this eye sees that instruction is now true, it tells the CPU goes through the rungs of logic that are programmed within it and says, oh, well, every time we see that input 000 is true, we need to activate output 000. So that CPU sends a signal down to this light. This light lights up. The resistance here drops down to nothing, and voltage gets applied to load number 1 from terminal 000. Okay, your output cards, your input and output cards can be of different voltages. Input cards, really common that they're just 12 volt DC. That's the voltage that a lot of the inputs run on. Outputs could be 12 or 24 volt DC, 24 volt AC, 120 volt AC. There's quite a variety of them. These are not fused at a whole lot. You only get a couple of amps out of each output card, so if your loads draw quite a bit of current, you might actually have to use the output to fire a relay to operate the load, or whatever the case may be. But if it's an LED light or something like that, they handle them just fine. And you can get output cards that have a little higher current capability. The input cards, they're fused at like half an amp. These light bulbs would actually be LEDs, which need next to no current to get them to light up. So not very much power available in these circuits. A little bit allowed in these circuits, but still not a huge amount, just enough to run some control devices. Okay, so that's what's going on inside the PLC, and that happens every time the PLC goes through its scan cycle. Well, what exactly is a scan cycle? Well, in your lines of logic, which is what we've programmed into the CPU, what we want it to do with all of those instructions, the CPU goes through the first line of logic, sees input 000. If it has been activated, it fires output 000. Then it moves down to the next line. If it sees input 000 is true, it moves on. If it sees 001 is true, then it'll fire output 1. Now, all of these aren't going to be true all the time, right? If these are, let's say, before we've pushed any of these push buttons, what the PLC will actually do is it'll start reading this wrong. Oh, input 000 is false. Well, I don't need to read any further here. I'll jump down to the next line. Oh, it's false. I'll jump down to the next line, right? So what the PLC scan cycle is just the CPU going through. If you put those scan cycles in terms of a person, it's almost like your head's going through a list. If this happens, I need to do this. Oh, well, this didn't happen, so I'll go on to my next task. If that hasn't happened, well, and I can't move on to that task, I'll move on to the next one. And that sequence just happens over and over and over again. So how fast the reaction is of the inputs is going to be based on how many rungs of logic that PLC has to go through before it gets back to this one. If there's 100 rows of logic, it'll look through each of those 100 and then it'll come back to number 1. If it's only a couple, it's pretty quick. But that continually happens on an ongoing basis. Start at the top, top to bottom, left to right. First rung, go until you find an instruction that's false, or you complete the rung, then jump down to the next rung. Okay?